Good morning, and today we're going to be looking at some of the different layouts of the way you can write the equation of the straight line. So we have got some different versions of them. So you remember this one from National 5, y equals mx plus c, but we can have them in different rearrangements of that, whether we have everything on the left hand side, some of it on the left, some of it on the right, and also a formula to be able to help us to work out what the equation of the line is. So let me just give you a reminder, because this is a reminder from National 5 of the y equals mx plus c format for the equation of the line. So if you remember, y equals mx plus c is the equation of a straight line, m is the gradient, and c is the y-intercept. The y-intercept is the number that it crosses the y-axis at. Okay. Find the gradient and the y-intercept of the line 5x plus 3y equals 4. Now what you should notice from this, and again this is National 5, is that this is not in the format of y equals mx plus c. We have the x's and the y's on the left hand side, we have the number on the right hand side. You've not got it in the correct format to just be able to pick out the gradient and the y-intercept. Okay, so the gradient is simply not just the number in front of the x wherever the x happens to be, and the number on its own is the y-intercept. Let's see what happens when we rearrange it to y equals mx plus c form and see what the numbers change to. So we must rearrange it if we want to pick out the gradient and the y-intercept. So first of all, the x is on the wrong side, it's on the left, and we want it on the right because we want it y equals mx plus c. But we also do not want anything in front of the y, so we've got 3 multiplying that y just now. So that 3 is actually going to have to go over to the right hand side. Because it's a times on the left, it's going to be a divide on the right. Now I could either write it as all over 3 or individually everything all over 3. So we've got a negative 5/3 x plus a 4/3. So both of those terms on the right hand side have been divided by 3. So now I have got it in the form y equals mx plus c. And I can now identify what the gradient is and what the y-intercept is. So the gradient is simply negative 5/3 and the y-intercept is simply 4/3. If it were to ask you for the coordinate of the y-intercept, you would write it as the coordinate 0, 4/3. Okay. Okay, so what if you have a question like this then? Show that the point 2, 4 actually does lie on this line y equals 3x minus 2. So we've got the coordinate 2, 4. Now just remember what a coordinate is. The first number in a coordinate is the x number. The second number in the coordinate is the y number. Okay, because you go along the x-axis and up the y-axis, don't you? So that's just the x. At x equals 2 and at y equals 4. Show this actually does lie on this equation of this line. So let's pick the x equals 2. Right, we've picked that out of the coordinate. Let's put it into the equation and see what the y value is. So where it's 3 times the x number take away 2, it'll be 3 times 2 take away 2. So that'll be 6 take away 2, which is 4. Now that's what we have here. It matches the coordinates. So when x equals 2, y does equal 4. So that means that the coordinate 2, 4 does lie on the line. So as y equals 4 when x equals 2, the point 2, 4 lies on the line with equation y equals 3x minus 2. So that's you proving it. So you're just putting part of the coordinate in and checking that the answer you get does actually match the other part of the coordinate. Okay. And here we have a different format. Basically, this is still the straight line because it's still just x, y, and number. Okay. But we call this the general equation of a straight line. When everything is on the left-hand side and the right-hand side is equal to 0, we call it the general equation. We also tend to write it in alphabetical order, so the x, the y, and then the constant. Okay, and then everything else is equal to 0. We also tend to take them, if we have to rearrange it, we take them onto the side that makes the x number positive. Okay, and that's how you start. So you always want to start with a positive x number and then everything else joins that on the same side. So it's an alternative form to the equation y equals mx plus c. It's just rearranged in a slightly different way. Things are on different sides of the equal sign. So a linear equation is an equation between two variables that give a straight line when plotted on a graph. Okay, so what if we have this equation here? Y equals 1/6 x plus 1/3 into the form ax plus by plus c equals 0. So we're going to have to get everything onto the same side and onto the side that makes the x positive. So I'm not going to bring everything onto the left to join the y there, because then my x would be negative if I were to do that. Okay. So first thing, we also do not have any fractions, so we have to get rid of the fractions. Okay, so to do that, we're going to multiply every term by the lowest common multiples of the denominator. So we're going to have to multiply everything by 6, and then that will get rid of the fraction there, but also that will get rid of that fraction there. We have to also remember we've got to multiply the left-hand side by that as well. So we multiply that by 6 by 6 by 6. So we've now got 6y equals, and that just becomes a 1x, and 6 over 3 is a 2. But look what I've done here. I didn't want to bring these over to my left-hand side, because then I'm going to have negative x to start with. And I want to have it all as a positive x. So I'm actually going to bring my 6y over to join this here. So I've got an x minus a 6y plus a 2. But I've just written it there rather than switching sides again. So x minus 6y plus 2, and that will be equal to 0. So actually that's 0 equals x minus 6y plus 2, but I've just done a switch at the same time. So I've got x minus 6y plus 2 equals 0, and that's that equation, which up there is in y equals mx plus c form, and here is in the general equation of the line. Okay, so we're going to look at exercise 1e and 1f today, selection of questions from both. And as always, message your teacher if you need any help, and send in photos of your marked work so we can give you advice and support. Good luck and take care.